In this webinar, we will learn about oxygen and its basic concepts. We will learn about what is oxygen, what is its role in normal body function, what is hypoxia and what is hyperoxia, what are the harms or potential toxicities of hypoxia and hyperoxia. Oxygen. Oxygen, expressed as O2, is a colorless, odorless gas which is essential for normal body functions. Oxygen is available to us from the atmospheric air. Normal oxygen concentration in the air is 21%. Oxygen is absorbed into our body from the air which we breathe in. Role of oxygen in normal body function. Oxygen is essential for normal functioning of each and every cell, the functional unit of our body. Primarily, it is required for synthesis of ATP or energy. This energy is used for synthesis of proteins, enzymes and is also necessary to carry out normal cellular functions. Lack of oxygen results in inefficient energy synthesis and depletion of ATP eventually leads to cell death. Measuring oxygenation. Oxygen delivered to baby is expressed as fraction of inspired oxygen concentration or FiO2. Oxygen is transported bound to hemoglobin as well as in dissolved form. Oxygenation can be expressed as partial pressure of oxygen or PO2, which is the pressure exerted by the oxygen dissolved in blood. Normal PaO2 in arterial blood is 50 to 70 millimeter mercury in neonates. Percentage saturation of oxygen or SpO2 is the percentage of oxygenated hemoglobin. Normal SpO2 is 90 to 95%. Hypoxia and hyperoxia. Hypoxia and hyperoxia are terms used to describe low or high levels of oxygen in blood respectively. It can be defined based on arterial PO2. Normal PaO2 is 50 to 70 millimeter of mercury. Hypoxia is when PO2 is less than 50 and hyperoxia PO2 more than 70 millimeter mercury. It can also be defined based on SpO2. Normal saturation targets is 90 to 95%. Hypoxia is when saturation is less than 90% and hyperoxia when it is more than 95%. Effects of hypoxia. Severe or acute hypoxia developing over short time affects almost all organ system immediately, particularly brain, resulting in poor activity or lethargy which progresses to loss of consciousness. Baby can also develop shock, decreased urine output, bradycardia and can progress to cardiac arrest if not attended to. Intermittent or prolonged episodes of hypoxia increases the risk of death and necrotizing enterocolitis in preterm infants. Hypoxia also causes periventricular leukomalacia in preterm infants, resulting in neurodevelopmental impairment. It also results in pulmonary hypertension. Effects of hyperoxia. Hyperoxia causes free radical injury, resulting in increased risk of bronchopulmonary dysplasia, retinopathy of prematurity and brain damage in an infant with birth asphyxia. Monitoring oxygenation. Clinical identification of hypoxia or hyperoxia is not possible. If not identified early, hyperoxia or hypoxia can result in complications described earlier. Continuous monitoring with pulse oximeter is essential. Oxygen saturation more than 95% may correspond to very high PaO2 values and thus relying only on SpO2 may fail to detect hyperoxia. Maintaining strict oxygen saturation targets is advisable to avoid both hypoxia and hyperoxia. Desired oxygen saturation target is 90 to 95%. To conclude, the key messages are: oxygen is essential for normal function of the body. Both hypoxia and hyperoxia are harmful to preterm babies. Monitoring by pulse oximetry is essential. Maintaining optimal oxygen saturation targets is essential to prevent harmful effects of hypoxia or hyperoxia. Thank you.